Right, here we're going to look at how energy can be transferred. We've said that energy cannot be destroyed or created, but it can be changed into other forms. Sometimes this energy is useful, sometimes it's wasted. If it's wasted, it normally ends up as heat, but an example of where it's not wasted is obviously if you want to change the energy into heat, like in a fire or something, that isn't wasted energy there. But normally, with most devices like lights and cars and other electrical devices, then we don't want to be producing heat. Right, so let's give an example here. We've got a car moving, and of course what's actually happened is this potential energy in the petrol, the chemical potential energy, gets changed to kinetic energy, moving energy, plus heat energy, plus sound energy. And if you had to measure the amounts, you actually find out that out of the 100 joules of energy put in there for petrol, that's a really, really small amount of energy, by the way, you might get 25 joules of kinetic energy, 73 joules of heat energy, and 2 joules of sound energy. And of course, if you add up the energy on the right hand side, it equals the energy on the left hand side. Now we call the energy that you gave the car input. Okay, input energy, and the output is obviously what comes out of that, the car engine as a result of that, which is moving energy, heat energy, and sound energy. This can be represented in a diagram called a Sankey diagram. It's a very common diagram, and the thing about Sankey diagrams is it's a way of representing energy transfers in a scale diagram. So what's important with the Sankey diagram is that the width of the arrows represent the amount of energy used. So for example, on the left hand side you can see we've got chemical energy 100 joules, and the thickness of that arrow is 4 centimeters. So it basically means that each centimeter is equal to 25 joules. Okay, so 1 centimeter is 25 joules, 2 centimeters is 50 joules, 3 centimeters is 75 joules, 4 centimeters is 100 joules. And that chemical energy gets changed to kinetic energy, and if you notice, the width of that arrow has to be 1 centimeter because kinetic energy has got a value of 25 joules. And then as you go down towards the bottom, the wasted energy, which should be 75 joules, therefore the arrow must be a width of 3 centimeters. So it's the scale diagrams you need. In the exam, they'll have these diagrams on graph paper, and you have to count up the little boxes, little squares. And there you go, the width of the arrows represents the amount of energy. You can do an equation for this, which is basically the efficiency. You may be asked to work out the efficiency of a machine. And the way you work out the efficiency, this is actually given to you, this formula is given to you in an exam, is efficiency is useful output energy divided by total input energy. In this case, the useful output energy is the 25 joules of kinetic energy. The amount of energy we gave to it was 100 joules, that's the input energy, so it's 25 divided by 100, which gives you 0.25. Now 0.25 is the same as 25 out of 100, or 25 per 100. Now per 100 is known as percent, so therefore 0.25 actually is 25%. So sometimes you may see the equation written down like this. Same equation, but with a times 100 at the end, and that's just basically going to give you the chance to write down 25% at the end of it. Now 25% is a fairly pathetic efficiency, but that is typical for a car. So you're wasting a lot of the energy you give to the car. So how can you make the car work better? Well, if you give the car a shape that is more streamlined, it won't waste quite so much energy. If you perhaps lubricated some of the things, so some of the engines, so it had oil on it, running it properly, that may stop heat energy being lost. And if you can use the heat energy properly for other reasons, then that would work as well. Now, that heat energy is more of a problem with power stations. You may probably be given a problem with power stations where they talk about burning coal or burning gas to create electricity, and what they'll say is that most energy gets wasted in the form of heat. Well, if you can capture that heat that would normally go out of the chimneys and use that to heat up people's homes, that is a more efficient power station. So if you can use the heat energy, because to be honest, most devices are heating machines. Also, if you can cut out noise, if your machine's being noisy, it means it's wasting energy to make noise. So there we go, that's a way of making it more efficiency. Note, by the way, all wasted energy dissipates. That is a really important word to use. Dissipate will get you the mark. And it dissipates in the form of heat. It means it spreads out in the form of heat, and that warms up the surroundings. That's such a common question. Keywords here, you must know what we mean by Sankey. You must know what useful energy, what wasted energy is. You must know how to work out efficiency. You must know the difference between input and output. And you must know that dissipates means to spread out, and the energy normally spreads out in the form of heat, and it warms up the environment. So there we go, that's everything you need to know about energy. and the transfer of energy.